Well, now we're going to talk about factorization. Question point 3, quadratic trinomials. Okay, form 1. Okay, this form of a squared x squared plus bx plus c. Now, we will first consider question 1, question 3, question 5, question 7, question 9, question 11, question 12, question 13, question 14. Okay, then we will consider question 2, question 4, question 6, question 8, question 10, and question 15. I'll tell you why. Now let's first do the questions in yellow. Okay, let's start with question 1, this one. Okay, question 1, right here, we have like x squared minus 11x plus 28. Now to factorize this, first we are going to put like x in the bracket like this. We put x in the bracket and then x in the bracket there. Okay, that's what we will do when we have this form. Okay, this form is when there is no coefficient in front of the x squared. Just place x's in the bracket like this. Okay, now we will then consider the coefficient of the last term, 28. Okay, in this case it is positive 28. Okay, so I'm gonna write here plus 28. Now I will list all the factors of 28 in ascending order preferably. Okay, so they are like 1 and 28. Okay, because they are factors of 28 because 1 times 28 makes 28, and then 2 and 14 because 2 times 14 makes 28, and then 4 and 7 because 4 times 7 makes 28, and that's all because the following will be a repetition of what we listed already. Someone may tell me 14 and 2. 14 and 2 is the same thing as 2 and 14 here. So now in the list of the factors of 28, we will see which couple will make a sum equal to the coefficient of the middle term, in this case negative 11. Okay, now let's see. With 1 and 28, there is no way for us to get negative 11. Even if we do 1 plus 28 or 1 minus 28, 28 minus 1 or 28 plus 1, it will never give us negative 11 here. 2 and 14, no, but 4 and 7, yes. This can generate negative 11 if we have like a negative 4 and a negative 7, because minus 4 minus 7 will be negative 11. So here I can just place in negative 4 and negative 7. Now we can say we fully factorize. Okay. I'm going to erase this. Now let's do the second question. Was question 3. Question 3. Here we have like x squared plus 6x plus 9. Okay. Now again, same technique. When we have this form, when there is no coefficient of x squared, we can just place in x in the brackets. Okay, I will place x in the brackets. Now I will consider the coefficient. The last term. Okay, the last term of the expression, which is what 9. So it's positive 9. I write positive 9 there. Now I'm gonna list all the factors of 9. Okay, in ascending order preferably. So we're gonna have like 1 and 9, and then 3 and 3. 1 and 9 because 1 times 9 makes 9. 3 and 3 because 3 times 3 makes 9. Now in the list of the factors of 9, I will identify that only which only couple that will make a sum equal to positive 6. There, in this case, you can see 1 and 9 will never give me positive 6, but 3 and 3 will. So this is going to be like positive 3 and positive 3, because positive 3 plus 3 makes 6. And obviously, positive 3 times positive 3 makes positive 9. So over here, within the bracket, I can place in positive 3 and positive 3 there. Now we can say we fully factorize. Okay. Raise this one also. If I do like question 3 there, I mean question 5. So we did this question 3. Now we're gonna do question 5. Okay, so to avoid confusion, erase this. Now we are by question 5. Question 5 says on right here, question 5, we have like a squared minus 9a plus 20. Okay, so over here we do the same, we apply the same technique. Okay, we will consider the last term, which is positive 20. Okay, now I'm gonna write here positive 20, and then I will list all the factors of positive 20. Okay, preferably in ascending order so we cannot forget anything. So I'm gonna be like 1 and 20, because 1 times 20 makes 20, and then 2 and 10, okay, because 2 times 10 makes 20, 4 and 5, because 4 and 5 makes 20. We can stop there because the following will be a repetition of what you already listed. Now, okay, over here we assume we already place A's in the brackets. Now we can select which couple will make a sum equal to the coefficient of the middle term, -9. Now you notice that with 1 and 20 we will never get -9, but with 4 and 5, yes, we will. If we do like -4 and -5, you see, -4 minus 5 makes -9, and of course -4 times -5 makes a positive 20 there. So we can place in here -4 and -5. This is how we can factorize. Now I'll leave 7, 9, 11, 12, and 13 for you to practice. Okay, it's gonna be always the same. Now I want you to notice one thing. Why I selected the yellow one first? Look at the yellow questions end with positive, okay, positive term, all of them, okay. So it's I do that on purpose. I did that on purpose. So this one, not 11, okay, because those ones end with a positive term. You see, when it ends with a positive term, okay, when a factorization, when we have a trinomial that ends with a positive number, within the bracket, it will always have the same sign. You see, like here, for instance, it's going to be negative and negative. Here, it's positive and positive, negative and negative. It's going to be like that all the time, positive and positive, or negative and negative. The signs will always be same when it ends with a positive number, okay? The sign will always be the same, either both negative or both positive. Now, let's see what will happen if we do the one highlighted here in pink. Now let's start with question 2. Here, question 2, we have like x² minus 5x minus 84. Now we do the same technique. We will first place in x in the bracket, okay, and then we're going to consider the last term, which is -84. I'm gonna write here -84. Now let's list all the factors of -84. Okay, they are like 1 and 84. Okay, 2 and 42, and then 2 and 21. I prefer to list all of them in ascending order. Okay, 2 and 21, and then no, not 2 and 21. I made a mistake. it's rather 3 and 28. Okay, if you're unsure, use a calculator. Okay, you can use a calculator like if I use a calculator, I will do like this. You take 84 divided by 2, you see it's 42, and then you can change. Also, you divide by 3 and then see what's going to be 28, and then you change again, you divide by 4 and then see how it's going to be. It's going to be 21. So 4 with 21, 4 with 21, and then is there anything else to do? Yes, 7. Yes, I can see with 7, with 6 maybe. Let's double check with 6. Yes, 6 and 14. Okay, 6 and 14. I knew already I cannot divide by 5 because it doesn't end with 0 or 5. So that's why I did with 6. And then with 7, yes, because 7 times 12 is so 7 and 12, like that. And then is there anything else to do? I think that's all. Okay, because the following will be repeating just what we already listed here. Now, I am going to see which couple, okay, will make a sum equal to the coefficient of the middle term -5 here. Now, let's see. If you check, you see that the only possibility to get -5 is if we manipulate 7 and 12. Okay, so if we have like a positive 12 minus 7, because the other way around, positive 7 minus 12 makes -5, and of course positive 7 times -12 will make -84. So these couples will give like the product must be this, the sum must be that. Okay, so positive 7 and -12. Now over here I can write plus 7 and then minus 12. Now over here you see, because it ends with a negative number, sign alternates. Okay, it's positive 7, positive, and then negative in the bracket there. Let's take another example. Another question. I'm going to take another question that I write in pink. Let's say question 4. There we are like x² minus 4x minus 12. Okay. So question 4. x² minus 4x minus 12. That one. We're going to place x in the brackets. Okay, and then we will consider the coefficient of the last term, which is the independent term, which is -12. I'll write here -12, and then I will list all the factors of 12. They are like 1 and 12, 2 and 6, 3 and 4. Okay. Now, in the list of the factors of 12, there must be exactly one couple, okay, that will make a sum equal to -4. Now, let's see. With 1 and 12, we'll never make -4. With 3 and 4, we cannot. But with 2 and 6, yes, we can. If we have like a positive, if this is a positive 2, and that's a -6. Okay, you see, it's gonna be like positive 2 and then -6 there. You see, that makes then we can say we factorize this, and then let's take the last one. In purple, let's take question 8 here. We have like a² minus 2a. Question 8. a² minus 2a minus 48. Again, we will place the variables a in the bracket like that, and then we will consider the last term, which is negative 48. So I'm gonna write here negative 48. Now all the factors of 48 are 1 and 48, 2 and 24, okay, 3 and 16, 4 and 12, okay, and then 6 and 8. So those are the factors of 48. Now, in the list of the factors of 48, there must be one couple, exactly one couple, which will make a sum equal to the coefficient of the middle term, negative 2. Now, let's see. Which one can it be? Okay, you can go through trial and error and identify. It's not always the last term, okay, because by luck or by I don't know, by coincidence, most of our answers were lying in the last couple of the factors of 48. So now, yes, like in this case, it has to be positive 6 and negative 8, because 6 minus 8 will make negative 2. So we can say plus 6 here and then negative 2. Now, I want you to notice that when it ends with a negative term, okay, sign always alternates, okay? If it's positive, like you can see those in yellow here, when it's end with a negative answer like that, a negative answer ends with a negative, negative, the signs of the factors will always alternate. It's going to be positive and negative, or negative and positive, always like that, okay? But when it's end with a positive number, the sign will always be the same. It's going to be positive, positive, or negative, negative. I hope you understand that. If you do like the video, please subscribe into our channel, and then hit the notification button, give us hands up, and then share the link with other students. Thank you.